Bismillah ar-Rahman ar-Rahim. This is teacher Iman explaining the sum and product of roots of a quadratic equation in complex number set. Complex numbers set. So you will have two rules now talking about the sum and the product. The first rule is the sum of the two roots of the quadratic equation. This quadratic equation is az squared plus bz plus c equal to 0. Then you have to focus on the sum by writing a plus, and the two roots are z1 and z2. We can easily having the value or the sum of them by having b from the coefficient of z and a from the coefficient of z squared, then divide them to each other, having their ratios and give them negative. So the rule will be z1 over or z1 plus z2 equal negative b over a, and we can use it easily. Now another rule is talking about the product of the two roots of the quadratic equation. From the same equation, be sure that it is equal to 0 before you're going to use it. Then the product can be written as z1 times z2 equals to the ratio between c and a. C is the constant term in the equation, and a again is going to be the coefficient of z squared. Now let's apply these two rules in the following questions. The first question is asking you to write true for true statement and false for the false one. The first question is the product of the two roots of the equation iz squared plus z plus 3 equal to 0 is negative 3. So you're going to use the rule of the product, which is z1 times z2 equals c over a. C is going to be the constant term and a is going to be the coefficient of z squared. Well, be sure that your equation is equal to 0. So easily you can write 3 over I. Take this I from down to up and change the sign to negative 3i, and compare your answer or your solution by the answer that you have, because it is the same, so it will be true. Let's go to question 2 and think about the sum of the roots of the equation iz squared minus bracket 1 plus iz equal to 1 is 1 minus I. The rule of the sum is gonna be z1 plus z2 equals negative b over a. Go back to the equation and focus on the b. You can see that b is going to be the coefficient of z, which is including negative and 1 plus I, and then a is going to be the coefficient of z squared. And focus on this negative in the equation and the other negative coming from the b from the equation, and that all will be divided by I. Because you have I outside and negative outside and inside, you can multiply them to get positive. So that will make it positive 1 plus I. 1 plus I divided by I. I can split this I here and there and simplify. You can divide 1 over I by taking I up and change it to negative, and that will be simplified also by dividing I with I to get positive 1. You can reorder your answer or this complex number by writing the real first, then the imaginary. Compare your answer with the answer that they have. You can see it is the same, which can make it a true statement. Number 3, the product of the roots of the equation is going to be easily taken from the equation, but be sure that it is equal to 0 always. The product is z1 times z2 equals c over a. Go to the rule and or the equation and find c, which is the constant divided by a, which is I. You can now divide 7 divided by I, take this I from down to up, change its sign to be negative, and that will give you this answer, which is negative 7i. Compare your answer with his, and you can't find the negative, so that will make it false. In number 4, you can see that you have if z1, z2 are two roots of the equation, is then z1 plus z2 equals to negative 5. When he said f, this means he is giving you something, so you try to use the given. z1 and z2 are two roots, so he is asking you to add them. z1 plus z2 will give you, according to the rule, negative b over a. He didn't say sum here, but he is writing a plus. That means he is asking for the sum rule. So b is going to be negative 5, which is the coefficient of z, and a is going to be the coefficient of z squared. Divide them to each other, but be sure about the negative from the formula and negative from the b, all divided by I. Negative by negative will be changed to positive, and you can get 5 over I. Take this I from down to up and change the sign to be negative 5i. Compare your solution with his. You can't see I written. That means it is false. Now we have to change the type of the questions to be choose the best alternative. And the first question in this type is gonna be if the product of the roots of the equation is given as a 3i, then he is asking you to find the value of k. I hope you have to start by the given, which is written by f. The word f is very important in your equation. F, the product here is 3i. So try to write the rule of the product, which is z1 times z2 equals to c over a. The product is given, which is a 3i. You can write it here to the left, and c is going to be the constant term by being sure the equation is equal to 0. So k is here divided by a, which is the coefficient of z squared. I can write I here. I can see that I have proportion fractions, so I can make it over 1. Now cross multiplication can solve this equation. By multiplying I from down to up and 1 from down to up, that will give you 3 times 3i times I will be 3i squared. To the left equals 1 times k is k. I squared is negative, so it will be negative 3 equals to k, and this is the solution of k. So my choice will give me the first to be the right answer, which is negative 3. Now in the second question, we can see that if the sum, again he is saying f, so focus on the word f, the sum of the roots of the equation is 2i, then he is asking you to find the unknown value, which is m. Now let's focus on the sum rule, which is z1 plus z2 equals negative b over a. Because 2i is the sum of the roots, so I will write to the left equals to negative b. I can keep this negative from the coefficient, from the formula, and go to this m and put it instead of b over a, which is I. I is the coefficient of z squared. Don't take z squared. Now make them over 1 to deal with a cross multiplication. I times 2i is going to be 2i squared equals to negative m times 1, which is negative m. I squared is negative 1, so times 2, negative 2 equals negative m. Divide both sides or multiply both sides by negative. That will make m finally equals to 2. And this is your solution. So I can choose the second one. Which is the second choice? It is 2. We can go now to the third. If the product of the roots of the equation 1 minus I z squared minus z plus n equal to 0 is 1 plus I, then n equals. So I'm gonna focus on the product rule. z1 times z2 equals c over a. The product is given by 1 plus I. I will write it to the left. 1 plus I. I can make it also over 1 equals c is given here, which is n, which is the constant term, divided by a, which is 1 minus I all. It is 1 minus I, which is the coefficient of z squared. Now I can make a cross multiplication easily by multiplying 1 minus I from down to up and 1 from down to up to get exactly or easily 1 plus I times 1 minus I all equals to n. Then, according to the rule of z times z dash, you can have, or any complex number multiplied by its conjugate will give you the real square plus the imaginary part squared equals to n. So you can get 1 plus 1, which is 2, and which is the value of n finally. So our choice will be the third, which is 2. In number 4, we can see that we have z1 and z2 are the two root solutions of the equation, and then he is asking you to multiply them. So you can use easily the product rule. z1 times z2 will give you c over a. Be sure that your equation is equal to 0, and c is going to be the constant term which has no z beside it. Negative I divided by a is going to be the coefficient of z squared, so divide negative I over I. That will make it negative 1. So our choice is going to be the last, which is the fourth, negative 1. In number 5, we can take easily f m comma 2I over m are the two roots of the equation, blah blah blah, then we need to find the value of a. So he didn't give you the product or the sum or whatever, but he gave you the two roots of the equations, and m is unknown and a is unknown, so you have two unknown here in this question. So it's better for you to use the product rule. The product rule easily will cancel m with m. So look, z1 times z2 equals to c over a, and z1 is m, z2 is 2I over m, equals to c is the constant term, which is 2a divided by a is 1 here because nothing is written beside z squared, which is 1. I can cancel this m by m, down and up, and you can get finally this 2I to the left and 2a to the right. By dividing both sides by 2 here and there, you can get rid of this 2, and you can have a equals to I is your solution, which gonna be choice number 1. Which gonna be choice number 1. In the sixth question, the sum of the two roots of the equation is, he is asking you about the sum, but the equation here needs from you to expand. You don't have z squared actually, so you need to expand it first. So what about multiplying z by I plus z by z, which gonna give you z squared minus 5I z, and try to equal it by 0 as we said, equal to 0. Reorder and add like terms. We can start by z squared, then these two can be collected together to be added by taking the like term. The like term is z, so I can say that it's a plus. Here I can have negative 5I and plus I all with z. minus 4 equal to 0. We can subtract them to get z square minus 4iz minus 4 equal to 0. Now, he is asking you to find the sum of the two roots. So the sum is z1 plus z2 equals negative b divided by a. Negative b is going to be exactly negative 4i. And take care about the negative from the formula and the negative from the b. Divided by a, which is 1. Now, negative by negative is positive, so the last answer is going to be 4i, which gonna be the first choice. It is here, 4i. Now, question 7, the sum of the two roots, which are including z bracket 1 plus iz equals to 5 is equal. Now we can do similar by expanding first this z by the first and z by the second to get easily z times 1z plus I z squared plus iz minus 5 to be sure that your equation is equal to 0. Now reorder them by writing iz squared first and add like terms which are z and iz. You can take the z as a common factor, then you can have 1 plus I together, and z is common, and 1 is coming from here, plus this I from here, and the z will be common, minus 5 equal to 0. Now, he is asking you to find the sum of the two roots. So the sum will have this rule, z1 plus z2 equals. The sum is negative b over a. The b is written from the coefficient of z, which is 1 plus I all divided by a, which is I from the coefficient of z squared. Now, we can let this negative get in and try to simplify. Negative here and negative here and negative there. So that will make it easily as negative 1 and negative I divided by I here and there. So if you're going to take this I from down to up, that will change it to positive, and you can cancel this I with this I to get negative 1. So your answer will be easily I positive and negative 1. If you want to reorder your answer, it's going to be negative 1 plus I, which is going to be the fourth choice. Good luck for you all. Wish for you the best.